On this episode of the Tech Stack, we're going to discuss NVIDIA's and Intel's brand new partnership and dive deep on the Rubin CPX announcement from last week. Coming up next. Welcome back to the Tech Stack, everybody. I am here with my compatriots, Jim McGregor. Jim, how you doing?
Good. Great. How you doing, Marco?
Good. Long time no see. And also here with Mark Vina. Mark, what's going on?
Just taking it easy in Las Vegas. It's raining. Believe it or not, it's raining today, which is good, actually.
You need it there once in a while. So we had plans for a particular podcast today, and then Intel and NVIDIA went and threw a wrench in the works. So we're going to discuss today's big announcement first. If you missed the news earlier this morning, NVIDIA announced that they're taking a $5 billion equity stake in Intel, and the two companies are going to partner up to develop an array of products, not just one single product. It was a really interesting announcement. It could have, in terms of Intel's, I'm not going to say credibility, but reputation in the market currently, it's definitely a big shot in the arm. In pre-trading, they were up something like 33% at one point. So let's start with Jim. Jim, what's your take on this announcement, and how do you feel this is going to impact Intel moving forward?
Well, the technology hell just froze over. So, I mean, let's face it. We're talking about two companies have been enemies or partners and enemies at the same time for years and years and years. So, but it's funny because when we looked at what would happen to Intel and who could buy Intel, the only name that came up was NVIDIA. So this may be a precursor to things farther on down the road. Obviously, NVIDIA doesn't want to get into semiconductor manufacturing, but taking a stake in Intel may be a significant move for the future. And quite honestly, it changes the dynamics of the industry a little bit. And I've talked to some people today, said, "Oh, well, it doesn't seem like that big of a deal." It does to me. You can say that they're also going to be doing a couple of other things. One, Intel is going to be using NVIDIA GPU chiplets in some of their mobile PC processors, and they're going to be incorporating NVLink into their server processors. Now, these are both big changes for the industry. I mean, one, it means that basically with an x86 processor, you're going to be able to scale past 8 GPUs in a server system. You're going to be able to do the whole NVL72 or NVL44 with the Rubin generation, not just with the Grace processor, but with an x86 processor once it's available, obviously. And that to me is really, really important because, it kind of, we've seen different technologies emerge, try to compete with NVLink. We've seen scale up Ethernet from Broadcom. We've seen UA Link, which Intel is a partner of, as well as a lot of other companies. But now you got to think that on the NVLink side, you've got Qualcomm. You've got Marvell, you've got Intel, you've got MediaTek, Synopsys, Cadence. I mean, people keep complaining that it's not an open solution, but the momentum seems to be around NVLink for that scale-up solution. And then on the PC side, obviously it's all about AI, and having that NVIDIA GPU integrated into, an SoC gives you a lot more AI horsepower.
Yeah, absolutely. This is, it kind of caught lots of folks off guard today. So I think everyone is still processing. This is potentially a seismic shift. Like, this is a really important partnership that really does a lot for both companies. Like, x86 is still really pervasive. Yes, NVIDIA has been focused on its ARM-based SoCs and processors for years now. But that doesn't, eliminate x86's pervasiveness in the data center. So there's lots of really cool potential here. Mark, what's your quick takeaway? How did you feel about the announcement this morning?
Well, like both of you guys, I was taken back a bit. One of these things, I usually generally wake up at 5 o'clock in the morning, and I, kind of glanced at my smartphone, and I saw a headline. But, this is evidence of, you got to read the entire article when you see a headline that kind of surprises you. At first, I thought, oh, wow, NVIDIA is actually going to partner with Intel and be maybe one of probably their biggest partner in the foundry business. And of course, today's announcement obviously didn't answer that question. It was based on a technology partnership. But I think this is a pretty big deal. I think its foundation, happened many moons ago when you could probably, I'm sure that this, they've been working on this back to the Gelsinger days. So this is not just something that's happened the last 30 days or so. But I think you have to be pretty naive to believe that this is not somehow tied to the equity investment that the U.S. government made in Intel. I have to believe, even though that was denied during the press conference this morning, I have a belief that there was some winking going on, and I think it'll be a very positive thing. And let's face it, with all the discussion about ARM and SoCs and things like that, and even Jensen acknowledged this, x86 is still the vast majority of the market. So it's not like this is chasing an architecture that's like x86 that's dying. So I think it's actually a win-win for both companies.
Yeah, I totally agree. And if you step back for a second, in just the last few weeks, Intel's essentially had nearly $16 billion in investments between SoftBank, the U.S. government, and now NVIDIA. Externally, personally, I've had many conversations with folks on how they feel Intel's going to evolve and what their outlook for the future would be. And lots of the external talk hasn't been completely positive. But talk about a vote of confidence, like $16 billion in just a few weeks. This could just be the beginning. There could be more. I too think this is a really positive development for both companies, perhaps not so positive for AMD. But yeah, and you know what else I'm going to mention, because you guys may not have seen this yet. On the call, there were a bunch of questions asked about NVIDIA potentially using Intel Foundry. And Jensen didn't really dodge the question, but said today's announcement is strictly about the partnership and collaboration and not about building chips in Intel's fabs. What wasn't said is Intel will most likely be doing some of the advanced packaging, right? And that is a key component to build SoCs using chiplets. Intel is arguably the leader in integrating chiplets onto CPU packages. So that's probably going to happen, even though it wasn't explicitly said. And after the press conference, we reached out to Intel to ask about the future prospects of Intel Arc GPUs, right? It's not like Intel doesn't have consumer GPUs. And Jensen and Lip-Bu were talking about using NVIDIA GPU chiplets on future mobile processors. So immediately in my head, I said, well, what does that mean for Arc? Intel responded and said today's announcement does not change their roadmap just yet, and Intel Arc GPU development will continue. So we're probably looking at a totally new class of parts that may not drop into the same sort of TDPs and form factors that we're used to. Could be something new. We'll see. Really interesting stuff. Jim, do you want to add anything before we switch over to the next segment?
Yeah, and I think that some people saw this as completely new. You have to remember that Intel several generations ago actually used chiplets in some of their processors from AMD. So this is not out of the realm of it. Also, you have to remember that this makes NVIDIA a key customer of Intel. And they're going to be buying they indicate they're going to be buying x86 processors from Intel, while Intel's buying GPU chiplets from NVIDIA. So it's definitely a win for both companies. And I agree with you. I think that we're going to see more going forward, not just on the product side, but I would expect to hear more about, whether it's on the foundry side, whether it's on the investment side. I think this opens up a lot of doors.
Yeah, and you have to wonder what it means for ecosystem partners, right? You now potentially have a totally new class of data center processor and consumer PC processor coming. So you probably have the likes of Lenovo, Dell, HP, wringing their hands, looking for some new product launches coming. Mark, anything you want to add before we close out and shift over to Rubin?
No, I would just violently agree with that, Marco. I think that I'm particularly very excited about what this is going to do to the thin and light notebook form factor area, because you combine x86, the comfort of being compatible with x86, the integrated power of a NVIDIA GPU, the improvements with power efficiency, battery life. So I really think, to your point, the Dells and the Lenovo's of the world and the HPs of the world, they're probably chomping at the bit of what this might yield.
Yeah, and you make a good point about power. Like I've essentially tested every GPU over the last 2 decades, and you may have similar performance at given price points between NVIDIA and AMD, but for at least the last 3 or 4 generations, NVIDIA has had a clear and easily measurable power efficiency advantage with their architectures. So even though Intel already has some low power GPUs, NVIDIA is the efficiency leader, but they're also the performance leader. So we could theoretically see some lower power, more highly mobile, ultrabook style machines with NVIDIA graphics, or more efficient, slimmer form factor because it's integrated higher end gaming notebooks. So this is just so much to digest, and I'm really looking forward to see what kind of fruit comes from this.
Yeah, the one thing I would add before we switch to the next topic is that NVIDIA has had a great eye contact solution for NVIDIA-based notebooks, but they generally you've had to use an external GPU. And if they can take that capability, just to give you one example, and provide eye contact correction, which is very heavily AI-based. I mean, can you imagine the payoff that's going to be with thin and light notebooks? So essentially, you have a studio with you. So I'm excited about that personally.
Yeah, and again, with an Intel next gen NPU, right? We're going to have tons of processing in notebooks. But yeah, we're speculating now here. So let's move on to some deep, rich technical content. NVIDIA also made news a couple of weeks ago and announced. Really, this was not quite out of the blue, but this was another somewhat of a surprise announcement from NVIDIA. So at a recent conference, NVIDIA announced the new Rubin CPX GPU. Now, we knew Rubin, the architecture name, was on NVIDIA's roadmap. Jensen's very open about NVIDIA's roadmap moving forward. But Rubin CPX is sort of a new animal, whereas most of the AI processors for the data center today, or up to today, featured HBM memory for massive bandwidth, and there's these highly integrated GPUs. Rubin CPX this is going to sound crazy, is somewhat akin to the architecture of a consumer GPU. It's using GDDR7 memory, and it's really dense and designed for more intensive compute workloads, not the massive memory bandwidth offered by HBM. But that means it's really kind of sort of tailor-made for specific workloads. Jim, you want to give the high level on what Rubin is, and then we'll start tunneling a little deeper?
Yeah, and to put this in context, they're calling it a context processing accelerator. So basically, you're going to have, for the Rubin generation, you're going to have the Vera CPU and you're going to have the Rubin AI GPU that are going to be handling kind of that ingestion of massive amounts of data. And this is really meant for very, very large workloads, like hours of video processing or millions of lines of code or deep research. And then basically, it's going to generate those first tokens, those contextual tokens, and hand it off to the Rubin CPX. And this Rubin CPX is going to do all that generation, that content or code or whatever generation of content that you're going to want. So it's really going to be an accelerator for the accelerator. But in kind of a broader context, you have to think of that as what we've been kind of thinking about for quite some time. That as we move towards more inference style processing, we're going to need some specialized accelerators, whether they're GPUs or ASICs or whatever, that are really tuned to handle different types of AI workloads for inference processing. And that's essentially what NVIDIA is doing. And they're building this out, not just with Rubin CPX, but it kind of fits into everything else that they've mapped out, especially since GTC earlier this year. It's going to work. They've got Dynamo, which is kind of their operating system for the data center to really orchestrate where workloads go and what workloads are running on what processing elements. It maps with the KV cache, so you can swap some of these key characteristics between GPUs for processing. It maps with their whole server design, because this is going to fit into their next generation NVL, what they call NVL 144, or the Rubin NVL 144 CPX solution. And all these other technologies that they've, especially their networking technologies, it fits in with them kind of building out that data center as a single system, not just a box, but not just a bunch of servers or racks, but it kind of fits in with that whole single system of having, with each generation, more and more efficient solutions for different types of AI workloads.
Yeah, for the uninitiated, right? I'm going to go super high level for a second. Lots of AI workloads, like they kind of start with a pre-fill phase where data is sort of ingested, and like the key value caches are filled, etc. That part is very compute intensive, but not really memory bandwidth intensive. And then there's like the decode phase, where tokens are generated, and things like that. That is often, performance is often limited by the memory bandwidth, which is why you're seeing more and more and faster HBM on the current AI accelerators. This new Rubin part kind of eschews this. It's still fast memory, don't get me wrong, 128 gigs of fast GDDR7, but the bandwidth can't match HBM. So it's really sort of tailor-made for that pre-fill phase and doing massive amounts of compute and sort of context-aware compute. Jensen had said, I believe he said something like, what was the Jim? What did he say about like a million pieces of context? What was Jensen's sort of context?
Well, it's got a million token context window, so it can take in
that's it,
like a million tokens and then generate millions of tokens based on that, whether they're for video, because Rubin CPX also has video encode and decode engines within it. So whether it's for coding, whether it's for video, audio, whatever, it's going to be able to take these massive context windows and then generate something based on that.
Gotcha. Yeah, that was the point that I was going to make next. Thank you for bringing me back on track. What lots of folks don't understand when they're working with Gen AI today, let's say you start with an initial prompt and you want to iterate and tweak as you go. The AI has got to keep all of those earlier prompts in context, right? It doesn't just forget them because it has to. And that as you go deeper and deeper, the compute workloads gets way more intensive the more context that's involved, and that's where this GPU is really going to shine. And then Jim also mentioned that the media engine stays intact on here. So if you're doing a video Gen AI workload, you now have processors that can do really fast, efficient video encode and decode as well. Mark, were you able to digest what NVIDIA's done here and sort of the implications of this new Rubin architecture that's coming?
Yeah, well, what's really going to be thrilling to see is that this architecture seems to be focused very much on, and you guys pointed out the example, long form video. I mean, when people are using Gen AI tools today, and they may not see the workload behind the scenes, you'll see it. There'll be applications out there. You pay a subscription for a bunch of tokens. You might be able to generate some really cool 15, 20-second videos. But that's not particularly relevant if you want to use Gen AI to create completely long-form AI. So I think they made the claim that because it can digest over 1 million tokens, I think they articulated that it could do more than an hour worth of video, which is, if you're Hollywood, you gotta fall in love with this kind of technology. So I think that's really interesting. I think from an ROI standpoint, I think that the claim was made, NVIDIA made the claim that for every $100 million, it could generate I think the number was $5 billion in revenue. That's not a bad ROI. So
yeah.
I'm sorry, go ahead.
I was going to say, no, it's interesting you bring that up because, and my memory may be failing me, but I think that's the first time Jensen's actually thrown a potential yield on a product like that to say, hey, spend 100 million with us, and I'm going to make you 5 billion.
5 billion.
Yes. Am I on track there, Jim? Am I correct?
Oh, absolutely. He's promising a 30 to 50x ROI on this.
Guys, maybe we should pool some funds together and pull something like this off.
All we need is 100 million. Come on.
Yeah, I mean, Jim, you got it. You got it in your PayPal wallet, I'm sure.
Yeah, nice work if you can get it. I mean, it's a stunning claim when you think about that. So. Yeah. I'm chomping at the bit to see what this is going to pan out to. Now, the question I have for Jim, though, if I could just, Jim, ask you a direct question. There is a kind of a long bit of a lead time before we see this. do we think the capability is going to still have legs a year from now or 2 years from now when we finally see it deployed? Or what's your perspective on that?
Oh, absolutely. Well, first off, they're tying it to, it's based on the same Rubin architecture. It's just the rest
Mhm.
of the GPU is architected a little bit differently. So I would expect that we're going to see, maybe even more versions of this going forward. And I think this is a natural progression as we evolve with AI. Not only do we need these new accelerators every year just to be able to keep pace with the rate of AI innovation, but we're going to need different types of it. So we may even see future CPXs, one that's just video, one that's just for encoding or programming, and one that's for something else. And this is for very large workloads. I wouldn't be surprised if we see something for the smaller ones. Matter of fact, I'm kind of surprised that it's been this long before we've seen these. But I think this not only does CPX have legs, but going forward, but I think we're going to see more and more of these more specialized or optimized, if you will, GPU accelerators for different functions. And you have to remember that, everyone's been saying, well, you can always do it easier or better with an ASIC. Well, an ASIC takes you 3 years to design. And, and quite honestly, a GPU is programmable. So, even if it wasn't designed for that workload, you can usually at least use it for that workload and still be somewhat efficient. So I don't see us moving away from GPUs. And I don't see, and it's funny because one of the other comments I get is, well, we're going to reach this point where everything goes to inference. We're already there. The vast majority of processing is already inference. So we need this technology today. And like Marco said, I think Hollywood is going to jump all over this.
Yeah, and and you're right. Like it's there's not going to be some sort of hard cut over inference, because as long as there's new things for the AIs to learn, training will be required, right? So, and one sort of adjacent piece of news or discussions that have happened recently that sort of ties in with this, I believe it was during MLPerf's recent disclosures. There were some partners that have started using sort of mixed GPU environments to test their AI performance. And like that's sort of what NVIDIA is doing here. It's still the same architecture, but you're going to mix the different styles of GPUs and different GPU configurations to optimize for your particular array of workloads. It's not going to be a single workload. And that's exactly what this does. One other wrinkle, and this is a complete speculation, intelligent speculation. I'm going to say hypothesis. The GPU on the Rubin AI that's linked to GDDR7 is very likely going to be the foundation of the next gen GeForce RTX cards as well. If you, assuming the die shot that NVIDIA released is accurate, the configuration is just like the current gen Blackwell desktop GPUs, just manufactured on a more advanced process with more cores, and we're sure some other special magic in there. So if that's true, this really speaks to the health of Rubin, that NVIDIA this early is making an announcement and putting this particular GPU configuration in, the cash cow in the data center. So yeah, really interesting development here. It's going to be interesting to see how this plays out. And I totally agree with Jim that I think, well, to answer your question, Mark, and to agree with Jim, a year from now, yeah, it's still totally relevant. And I think you're going to see more of this from multiple companies moving forward, not only as previous gen investments start getting retired and used for something else, and people make new investments in NVIDIA or AMD or whoever. What are you going to do with all that? You're not going to throw it in the trash. You can use it for something else. So right. Yeah, like we're entering a phase where the software has evolved to the point where you can have mixed environments. And now, the leader in the space, NVIDIA, is sort of here's clearly, a mixed environment with two different GPUs doing, optimized for different things. So really, really interesting to see how this evolves.
It makes it harder to justify doing a custom ASIC if NVIDIA keeps inventing new things. I talked to one company about this. And he says, we were doing some of this hard stuff, and then 6 months later, NVIDIA comes out with a solution for us, whether it's hardware or software. If NVIDIA keeps on this track, it makes it really hard to do your own ASIC or your own accelerator if NVIDIA is on this track.
But even in that scenario, NVIDIA wins. I mean, to me, that might be it's an interesting observation, but I think that's part of the strategy. So
Yeah,
they win in that scenario.
Yeah, so like it's really hard to do an ASIC in an industry as rapidly evolving as AI, right?
Yeah.
For, way back in the day for crypto mining, yeah, right. The workload didn't change. You knew what you were working on. All right, so some cheap ASICs come out and GPUs weren't as efficient for crypto mining. But we're still in the early days of AI. Like these workloads are really evolving, which, now I'm going to pose an unrelated question because this is something that's been rolling around in my head. To date, I kind of feel like everybody's brute forcing the AI workloads. It feels like the early days of 3D graphics where just make the chips bigger, have more bandwidth, put more cores in there, more cache, just brute force the whole thing. The only way like NVIDIA's dominance is sort of challenged is if somebody comes along and changes the math, changes how we do these workloads. Do either of you think that's a possibility? Like, I want to start with you, Mark. Do you think potentially there's someone lying in wait that's going to change the game with different math or a different style to do these sort of AI workloads?
Well, I think it's going to require a completely different thought process and a different approach about looking at what's going on here. And I think the example you brought up in the old days, where people tried to do that brute force type of thing. I mean, to me, it all comes down to cost efficiency, scalability. It comes down to endorsements, partnerships. NVIDIA has always done a great job with endorsing. I want to say Runway and Cursor came out supporting the Rubin capability. So I just think that people are going to have to think a little bit differently about where they approach it. And I think the point you made, Marco, the AI landscape and the AI ecosystem is changing so rapidly that, NVIDIA shines when you partner with NVIDIA, and if you hitch your star to them from a product solution standpoint, I don't want to use that old phrase, you never got fired because you bought IBM. I'm using an old phrase. I think NVIDIA is becoming such a juggernaut in the AI space that and they move for a big company. They move very briskly. They continue to innovate. And this is absolutely a proof point based on this. But I think people are going to have to look at, they have to look in the rearview mirror saying, well, maybe that wasn't the most efficient way to do this. So from my perspective, I think this has got a lot of traction.
Yeah. Jim, what do you think? You think there's a possibility of an AI revolution and sort of the market getting flipped on its head with the new way to handle these workloads, or are we on this path for the foreseeable future?
Well, I think there's always that opportunity. And obviously, we've seen a lot of companies innovate in certain areas. A company called Modular is trying to replace the software stack so it's completely independent. So for any type of GPU or AI accelerator. And there's other companies working on different forms of math to make the AI processing more efficient. But the real challenge here is you have to scale it. You have to scale it not just up to a chip, but you have to scale it to the data center level to really make it efficient. And at this point, I don't see anybody that is really thinking on that scale other than NVIDIA. I mean, they even have blueprints now for data centers running on Omniverse. So you can actually take a blueprint for what they call an AI factory on Omniverse, tweak it according to your power limitations, your thermal limitations, the configuration you want, any other customizations, and have a full digital twin, not just for design, but also for construction and operation of that data center. And I think there's innovation and efficiencies to be had throughout the value chain of AI, but displacing the track that we're on right now because it's changing so rapidly, it takes somebody that thinks at the level that we're now operating at, and that's the data center level.
Yeah, and NVIDIA is such a juggernaut right now. They're kind of vacuuming up all the talent in this space too. So I'm not going to. Lots of the major innovations are going to come from the leaders because it does require massive scale and huge engineering efforts, and for someone to come along and sort of flip it on its head, probably not going to happen in the short term. You brought up the digital twin, so that was a really interesting announcement. That was from Cadence, that Cadence has developed a full digital twin of NVIDIA's SuperPod. So yeah, you can now completely simulate a data center build. And they have, Cadence has something like 17,000 other partners and models for the equipment that's used in an AI factory or a large data center. So before you put a single brick on the ground or dig the first hole, you can completely simulate a data center now to a gigawatt scale with chip level accuracy. So you can literally simulate what would happen if one of the chips in one of the racks failed. That kind of resolution and accuracy, I think Jim's totally right. It's going to potentially change the efficiency, the layouts, the designs of these AI factories, and we could see, huge growth moving forward. Right? It's really interesting. But we kind of got off the path. We're gonna jump back to Rubin for a second. I think we covered all the pertinent details. Jim, is there anything I missed or anything that we should make sure everybody learns about before we close out?
Not that I can think of. I just would reiterate that Rubin is part of a bigger platform, and people have to remember that. And I think this is an important step for NVIDIA, seeing them realize that, there's not a single GPU for every workload. And they're recognizing that and trying to come up with alternative SKUs for their architecture. They're going to fit different types of workloads. I would expect to see a lot more of that going forward. Yeah,
totally agree. Mark, any closing thoughts?
Just that from a scalability standpoint, from an efficiency standpoint, from an innovation standpoint, I think NVIDIA continues to deliver. And to me, this is just another proof point that's part of it. So again, me being kind of an entertainment guy, you guys know me, I love movies. What this is going to do to the marketing agency sector and to the advertising sector and to even the full motion picture and the television industry, even though there's part of that industry is scared to death of AI because of the loss of jobs and things like that. If you're a producer or you're a Hollywood exec that's trying to contain costs, this is music to their ears.
So is it real or is it NVIDIA? No, I'm just kidding.
Is it bad that I know that was an old Memorex commercial?
Oh, yeah.
Are we showing our age? All right. And you know what? And with that, we should probably wrap things up. I would want to thank you guys for hanging out on the Tech Stack. If you want to catch more episodes, please like and subscribe to the channel. We are all over the web already. This is a fairly new platform for us, but we are on YouTube, we're on Spotify, we are on Apple Podcasts. We have our own website where we're syndicating some of our other content from our other channels. It's thetechnologists.net. And we hope you come along for the ride with us. All of us here on the Tech Stack, a couple of the guys weren't available for this particular episode, but we have a team of great analysts that we're all working together to produce this content. And we hope you enjoy the discussions. And if you do, please tell your friends about us, like and subscribe, and stick around for the next episode. Thanks for watching.